Ako si Gabriel Mesa at ang re-report ko ay software testing. What is software testing? Software testing is critical producing good quality software. Ang software testing kasi parang siya yung nagpa-finalize sa gawa mo, sa ginagawa mong software, kung ito ba ay may good quality, kung maganda ba ang pagkakagawa at kung may benefits ba na mangyayari kung kunwari kapag gumawa ka ng software, kung wala namang kwenta, edi wala ring benefits sa iyo yun. Parang siya yung nagpa-finalize kung pwede mo nang i-deliver dun sa client yung software na parang na dinedevelop mo para sa client. It is one of the last activities in software development before the software is delivered to the client. Yun na nga, kung ito yung nagpa-finalize sa software na dinedevelop mo para maibigay mo na ito sa client, kasi kailangan mo namang testing muna eh. Lahat naman ng bagay na kailangan mo na itinetest bago ma-finalize yon. Syempre, kung di mo i-double check yung mali mo may mga error pala dun na hindi mo na malayan. Yun. After the idea of building software was conceived by the client, it has undergone a series of transformation through the stage of planning, requirement, specification, design, and implementation. Ayun na nga. Bago yung pagtapos ng software testing, ito na yung mangyari. Parang magkakaroon na siya ng stage para maging na siya, software na talaga. Magkakaroon siya ng mga requirements, specification, at mga implementation. Importance of software testing. In the same way, when during software testing, it is found out that implemented software is not doing what it is expected to do by the developers themselves and the client, then the situation has to be remedied systematically. How do we do this? It will either need readjustments to the software implementation, redesign of the system, re-evaluation of requirements, or at the extreme, a total rebuilding of the system. Syempre, ito na nga yun sa importance, makikita natin kung hindi nga kung hindi mo nga na testing yung software na yon. Ito na yung sinasabi niya na situation na pwedeng mangyari. Baka hindi magawa ng software na yon yung dapat niyang gawin. Edi ang dapat mong gawin, ulitin lahat simula sa umpisa. Edi sayang naman. Kaya ito yung mahalaga sa software testing. Kailangan test mo muna bago mo i-finalize yung software na dinedevelop mo. This is the reason why the predicing phase will have to be carried out carefully and systematically to avoid such catastrophe from happening. And software testing is the phase in the software life cycle that ensures that the software to be delivered to the client has been tried and tested to standard, thus ensuring good quality software. Yun na nga, sa sinasabi dito, para kailangan talaga careful yung paggawa ng software, pagde-develop ng software. Kasi hindi naman biro-biro ng paggawa ng software eh. Kaya kailangan munang i-test bago parang step by step para siya, ma-ensure na good quality software talaga siya. The objective therefore of software testing is to detect or uncover errors in the system and consequently correct them by evaluating the existing system against its original specification. Ito yung isa sa mga objective nito. Yung una, dinedetect niya yung mga uncover errors sa system. And tinatama niya yung tinatama niya yung mga ano, sa pamamagitan ng pag-evaluate ng existing system sa original specification. Although there is not much attention given to testing, surveys shows that software survey shows that software testing takes up about 40% of the total project effort in the development, and highly critical system where correctness is of utmost importance. Due to the risk in lives and nature, software testing demands more than usual. Much has to be invested to software testing to achieve the goal of coming up with good quality software that is reliable and complete. Sinasabi nga dito na demand daw yung pag pag-testing ng isang software kasi sa panahon ngayon, kung hindi mo ito-test yung iyong software, kunwari pagka siya ay inano mo na, yung parang finalize mo na siya, yung software mo maaring ma-hack yun. Syempre hindi mo naman malalaman kung ano ba yun, kung secure ba talaga yan, kasi hindi mo na testing bago mo ma-finalize eh. Kaya kailangan reliable yung software mo at complete para sure 100% na na maano yung software na secure. Limitation of software testing. The next issue that we want to look at is the extent to which software testing can detect and correct software. Is it really possible to make sure that the software is free from errors? Ayun na nga sinasabi dito. In the process of doing your diploma in computer science, do you remember a time that you submit your programming assignment or exercise and you were 100% sure that it was free from errors? Even if the code has been tested and debugged extensively enough, it may not be possible, at least in most cases, to exhaustively test your code. This is because of the following truth. Software testing shows the presence of bugs but not their absence. Ayun. Sinasabi na nga yung kung ano yung limit ng software testing. Pinapakita lang nito yung bugs, pero hindi niya nakikita yung parang hindi niya pinapakita kung saan yung bugs na yun. Kunwari ito yung sa sinabi nga dito, if the code has been tested and debugged extensively enough, it may not be possible, at least in most cases. Kung yung code mo na ginawa is na debug, hindi mo sure kung meron pang natira nun, kasi hindi hindi siya parang na-test ganun. Obviously, we can only correct the error that we can find, but we cannot correct those that we are not aware of. This is the major limitation of software testing. Ayun na nga, yun sa sinasabi, kaya natin i-prevent yung errors, pero hindi natin kayang makorek kung hindi tayo aware, o kailangan talaga is mausisa. Kailangan tignan mo yung buong code mo para malaman mo kung ano yung mali. What we can do is to make sure that the tests that we perform are extensive enough, and this module will teach you how you can do this. Ayun na nga, dito sa module na to, pinapakita lang na kailangan talaga na na careful ka sa paggawa ng software, kasi hindi mo naman talaga malalaman kung ano yung
Hi, I'm Trisha Gale. Ang topic na napunta sa akin is General Procedure for Software Testing, Errors in Software, tsaka Software Testing Technique. General Procedure for Software Testing. The implemented system is to be dissected and scrutinized during software testing. Figure 12.1 shows the general procedure flow in software testing, where the components in boxes are the functions or events, while the others are the entities involved in the performance of the function. Kagaya nga ng pinapakita sa figure 12.1, para na matest natin yung software system, kailangan natin ng sets of test configuration. Kapag nasa part ka na ng pagte-testing, expected natin na meron ka ng sets of test configuration. Kasi kailangan yung pagplanuhan ng maayos kasi sabi nga ay a good testing method must be well planned, thorough, systematic, able to uncover different classes of errors and complete. Kasi doon nakasalalay kung anong kalalabasan ng software system na ating dinedevelop. Once na test, tapos ka na mag-testing, syempre magkakaroon tayo ng test results. Tapos, yung test results na yon, i-compare natin yun sa expected results. Pag napag-compare natin yung dalawang yon, yun na yung evaluation. Pag nag-evaluation na tayo, doon natin makikita kung may errors ba. Once na may na-detect tayong error, kailangan natin siyang i-debug. Tsaka, kailangan natin hanapin yung source ng error para maayos natin yung software system. Kailangan natin itong i-correct kasi kailangan natin mag-comply dun sa specification na kinakailangan para dun sa software system. Yung next concern mo pagkatapos nyo is yung how do we compare and contrast the test results and the expected result so we can detect error in the system. Tsaka yung how to perform the evaluation. Halimbawa, yung level of accuracy of data outputs ng ating application or ng software, kailangan i-identify mo siya explicitly. Thus, kailangan expected na pag nag-test ka nga, kailangan malaman mo kung ano yung error. Kaya lang, mahirap talagang hanapin yung source of error. Tsaka, sa debugging, nakadepende pa yun sa kung anong klaseng error yung na-detect. Yun yung rason kung bakit yung testing is the crucial part. Hindi natin mape-predict kung ganong oras or effort yung kailangan natin para sa detection at saka sa debugging. Ayun nga, pagkatapos mo mag-detect tsaka mag-correct ng error, kailangan nyo pa rin i-address tong dalawang questions. What is the assurance that the debugging really fixed the error? Tsaka yung, what is the assurance that debugging did not introduce more errors and possibly more complicated ones? Kailangan din na ulitin-ulit yung test pagkatapos mag-debug para ma-assure lalo kung okay na yung software system. Minsan may mapapatanong ka kung, ayun nga, what if software testing does not detect errors in the system? How do we interpret this? May dalawang posibleng interpretation pagka hindi na na-detect yung error. Bali, yung unang klase is the software has no errors, ayon kay Fairley. Pero ang ibig niyan sabihin dito the number of errors detected is proportional to the numbers of remaining errors in the system. Bale, pagka may konting error kang na-detect, ibig sabihin nun, yung pagde-debug mo ay malapit na matapos. Pagka naman marami kang na-detect na errors, yung pagdadebug mo ay nagsisimula pa lang. Yung pangalawa naman, ayon kay Pressman, the tests are inadequate to uncover the errors. Pwedeng yun nga yung dahilan kaya wala kang na-detect na error kasi mali yung ginamit nyong test configuration. Sabi nga kanina, importante na pag-isipang mabuti kung anong klaseng test configuration yung gagamitin nyo para ma-detect talaga kung may error ba dun sa system or wala. Errors in software. Bago tayo makarating sa part na tinetest na natin yung product, syempre, dumaan muna tayo sa iba't ibang stages ng development. Una, yung planning and analysis, where yung idea natin para sa software ay pinorm natin siya into words and diagrams. Then, sa part ng design, dun tayo naglagay kung anong methods ba yung kailangan natin para mabuo yung software. Then, sa part na implementation, dito na talaga yung nagko-code tayo or nagpo-program at tinatranslate natin yung design natin into a program with the use of programming language. Dahil ang pagpa-program ay nagre-require siya ng human input, dito na rin na-introduce yung errors. Sabi nga, fallibility of humans to exactly communicate what we think and perform as we should affect every aspect of the development and the eventual software system implemented. Errors are not mainly attributed to human errors in the development team. This may also be due to the uncertainty of client specification at the beginning of the project development. It can also be because of complexity of the system, its size, and the number of people involved in the development. Ayun nga, yung errors sa isang software, hindi lang naman siya dahil sa human errors. May iba pang aspects na nakaka-apekto kung bakit nagkakaroon ng error. Pwedeng yung complexity of the system, pwedeng yung size, yung number ng people na involved dun sa development, or pwede rin yung uncertainty of client specification sa beginning ng project development. Marami talagang rason kung bakit nagkakaroon ng error sa isang software. Pero ang pwede nating gawin, pwede nating i-minimize yung errors by adopting the methods suggested in software engineering. Pero sa totoo lang, minsan, some developers hindi pinapansin yung warning. Kaya, ang nangyayari, dun sa later part ng pagde-develop nila ng software, dun nila nakikita yung mga pagkakamali. Bale, sabi nga, sa isang Bible verse, what you reap is what you sow. Kung simula pa lang, inayos na nila yung pagpaplano, inadapt nila yung methods na sinasuggest sa software engineering, edi mas mare-reduce yung errors sa software system na ginagawa nila. There are different types of error and may be classified in various ways depending on the point of view. Ayon kay Lamb, classify niya ito as logical, overload, timing, performance, throughput, and hardware or operating system errors. This classification is mainly based on the effect of the error to the behavior of the system. Ayon kay Fairley naman, classified niya ito sa tatlong klase, yung requirement, design, tsaka implementation, which are according to the pace, in the development in which the error was introduced. Because of the enormity of the task in software testing, we need to employ suggested techniques to successfully perform software testing to our software system. Without this technique, finding an error in your software system is like looking for a needle in a haystack. We need a well-planned, systematic, and thorough method to detect errors. Software testing techniques. Majority of the tasks in software testing is in the design of the test configuration that have the highest likelihood of detecting errors in the software system, of course, in minimum amount of time and effort. Software testing techniques can be employed to help us in the design of these test cases. These techniques have largely evolved during the past several years. Now they can be classified into two main methods, white box testing and the black box testing. Yung black box testing is, pagtetest siya ng software na yung internal structure, design, implementation na tinetest ay unknown dun sa tester. While yung white box testing naman is a software testing method na yung internal structure, design, tsaka implementation ay alam nung tester. Kung magde-decide ka kung alin sa dalawang methods yung gagamitin mo, kailangan talagang pag-isipan mo siya mabuti kasi pareha silang may advantages at disadvantages. Minsan, okay din kung ipagko-combine mo yung dalawang method na yan para i-test yung software nyo.
White box testing, also known as structural testing or code-based testing, methodology which ensures and validates a software application's mechanism, internal frameworks and objects and components. Advantages: code optimization by revealing hidden errors. Transparency of the internal coding structures which is helpful in deriving the type of input data needed to test an application effectively. Covers all possible paths of a code, thereby empowering a software engineer team to conduct throughout application testing. Enables programmer to introspect because developers can carefully describe any new implementations. Test cases can be easily automated, gives engineering-based rules to stop testing an application. Disadvantages: a complex and expensive procedure which requires the adroitness of a seasoned professional, expertise in programming and understanding of internal structure of a code. Updated test script required when the implementation is changing too often. Exhaustive testing becomes even more complex using the white box testing method if the application is of large size. Some conditions might be untested as it's not realistic to test every single one. Condition testing is another structural testing method that is useful during unit testing using source codes or detailed pseudocode as a reference for test design. Its goal is the thorough testing of every condition or test that occurs in the source codes. It's a test case design method that focuses on testing each condition in the program. Advantages: it can organize program into logical segment of code that run only if certain conditions are met. It only makes a program more robust by allowing only a portion of code to run if a condition has been met. Statement testing, a test strategy in which each statement of a program is executed at least once. It is a weaker testing strategy than fat testing or branch testing because it usually requires the least number of test cases. Advantages: confirms code quality. Statement coverage confirms the quality of the code by ensuring that every statement is executed at least once. Check the flow of a statement. Statement coverage verifies the flow of the statements. Disadvantages: covers true conditions only. Restrictive in nature as it cannot test those conditions that are false. In other words, only true condition can be tested. This happens because it fails to understand the logic operators. Cannot check if loop reaches termination. Codes tend to consist of loops, but statement coverage fails to validate if the loop reaches its end of termination.
Path testing. What is path testing? Path testing is a structural testing method that involves using the source code of a program in order to find every possible executable path. It helps to determine all faults lying within a piece of code. This method is designed to execute all or selected paths through a computer program. Nakatulong ang path testing upang matukoy ang lahat ng mga pagkakamaling nakapaloob sa bawat code. Step for basis path testing. 1. Draw a control graph to determine different program. 2. Calculate cyclomatic complexity metric to determine the number of independent paths. 3. Find a basis sets of paths or generate test cases to exercise each path. Advantages of basic path testing. It helps to reduce the redundant tests. It focuses attention on program logic. Bali nakapokus lang siya sa logic ng program. It helps facilitates analytical versus arbitrary case design. Test cases which exercise basis set will execute every statement is in a program at least once. Disadvantages of path testing. Presence of defect cannot be traced by the path testing due an error in the specifications. Hindi daw matitrace ng path testing kapag mali ang specifications. Path testing requires expert and skillful testers with in-depth knowledge of programming and code. Ang path testing ay nangangailangan ng mahusay at skillful tester na maraming kaalaman pagdating sa programming. Loop testing. What is loop testing? Loop testing is defined as a software testing type that completely focuses on the validity of the loop construct. It is one of the part of control structure testing, path testing, data validation testing, condition testing. Ang loop testing naman ay tinutukoy din bilang software testing type kung saan nakapokus sa validity of construct loops. Why do loop testing? Loop testing is done for the following reasons. Testing can fix the loop repetition issues. Loops testing can reveal performance capacity bottlenecks. By testing loops, the initialized variables in the loop can be determined. It helps to identify loops initialization problems. Types of loop tested. Example of types of loop tested are simple loop, nested loop, concatenated loop, and structured loop. Sa simple loop, a simple loop is tested in the following way. Yan po yung example ng simple loop. Sa nested loop naman, you need to follow the following step. Kailangan mong sundan yung mga step para makagawa ka ng nested loop. Concatenated loop. In the concatenated loops, if two loops are independent of each other, then they are tested using a simple loops or else test them as netted loop. Sa concatenated loop, kung ang dalawang loop ay malaya sa bawat isa, pwede mo siyang gamitan ng simple loop o kung hindi naman ay nested loop. Yan po yung example niya sa concatenated loops. And unstructured loops. For unstructured loops, it requires restructuring of the design to reflect the use of structured programming construct. Sa unstructured loop naman ay kailangan ng pagbuo ng design upang maipakita ang paggamit ng structured programming design. Yan po yung example ng unstructured loop. Kailangan din po sundan yung following step para makagawa ng unstructured loop. Black box testing. What is black box testing? Black box testing is a software testing method in which the functionalities of software application are tested without having knowledge of internal code structure, implementation details, and internal paths. Black box testing mainly focuses on input and output of software application, and it is entirely based on software requirements and specifications. It is also known as behavioral testing. Ang black box testing ay isang pamamagaan ng testing software kung saan ang mga functionalities ng software application ay nasubukan ng walang pagkakaroon ng kaalaman tungkol sa internal code structure. Nakapokus din ang black box testing sa pag-input at pag-output ng mga software application. Kilala rin ito bilang behavioral testing. Types of black box testing. Functional testing. This black box testing type is related to the functional requirements of a system. It is done by a software tester. Ang functional testing ay nauugnay sa mga kinakailangang requirements sa isang system. Non-functional testing. This type of black box testing is non-related to testing of specific functionality, but non-functional requirements such as performance, scalability, usability. Ang non-functional testing naman ay hindi nauugnay sa specific functionality. Regression testing. Regression testing is done after code fixes, upgrades or any other system maintenance to check the new code has not affected existing code. Ang regression testing ay hindi nakaka-apekto sa ibang code. Ito po yung example ng black box testing. Advantages of black box testing. Tests are done from user's point of view and will help in exposing discrepancies in the specifications. Nakatulong ito sa paglantad ng mga pagkakaiba sa mga specification. Tester need not know programming language or how the software has been implemented. Hindi kailangang malaman ng mga tester ang mga programming language o kung paano ginagawa ang software. Tests can be conducted by body independent from the developers, allowing for an objective perspective and the avoidance of developer bias. Hindi pwedeng gawin ng developer na pagkakahintulot sa pananaw at pag-iwas sa developer bias. Test cases can be designed as soon as the specification are complete. Disadvantages of black box testing. Only a small number of possible inputs can be tested and many program paths will be left untested. Posible na ang maliliit na number lang ang itest at karamihan sa mga program path ay posibleng hindi magamit. Without clear specification, which is the situation in many projects, test cases will be difficult to design. Kung walang malinaw na specification, mahihirapan magawa ng design lalo na kung marami project ang gagawin. Tests can be redundant if the software designer developer has already run a test case. Ever wonder why a soothsayer closes the eyes when foretelling event? So it almost the case in black box testing. Katulad ng isang nakapikit na manghuhula, kapag hinuhulaan ang mga aganapan, ay gayon din ang halos kaso sa black box testing. Yun lang po, thank you.
Hello, I'm Brian King PECHO from BSIT3B, and this is my report. Combination factors. The white box testing method uncovers the errors in the logical level of the program, but with the danger of paying too much attention into the code's internal structure. The black box testing deals with the functional requirements of the software through the interface, but with the danger of paying too much attention into the code's internal structure. Rather than choosing one over the other, we can combine these two methods, depending on the system that we are handling. Unit testing. Unit testing performs error detection and debugging on the smallest unit of the software system, commonly called modules. When the developer has acceptably performed tests on the modules, the next step is to allow other members of the software team to review these modules. This is called a program review. Program reviews may be of two forms: program walkthrough and program inspection. A program walkthrough is an informal meeting where the developer of the module presents the software and allows the other members to find errors of the system. A program inspection is more formal in nature. It is similar to the program walkthrough, but this time checks the program against program design and requirements specifications. After unit testing is performed on individual modules, the integration testing and system testing are conducted. Integration testing. Once the modules are individually tried and tested, we are now ready to combine these modules together into one working software system. Integration testing is a systematic approach to constructing the program structure of the software system while interfacing the different modules of the system together.
Salamat sa pakikinig.
Good day everyone, my name is PERA and I'm here to discuss about top-down approach, bottom-up approach, and system testing. First, the top-down approach. The top-down approach, as the name implies, integrates the units from the main structure of the software and then downwards. The integration using the top-down approach performs the following steps. Firstly, the main module serves as the test driver, and stubs are implemented to replace all modules under the main module. Consider the entire control flow of a software system shown in figure 12 to 8. Stubs, stub 2, stub 3, and stub 4 are used to replace modules. Module 2, Module 3, and Module 4 respectively as shown in figure 12 to 9. Tests are performed on the main module. Second step, stubs are successively replaced with the corresponding module. As each module is integrated, tests are conducted on the existing system. The sequence of replacement of the stubs at various points in the integration is determined by the integration approach selected, whether depth first or breadth first. This is depth first integration that traverses the control flow using pre-order, meaning it will proceed to the leftmost child module not yet integrated. S2 is replaced by M2, followed by a replacement of S5 by M5. Notice that the same procedure is followed as in step 1. When S2 is replaced by M2, the stubs for the subordinate modules to M2 are also integrated. These stubs are S5 and S6 for the modules M5 and M6, respectively. This is followed by a replacement of S5 by M5. And this is breadth first integration that traverses the control flow using level order, meaning it will proceed to the siblings module or the cousins module if the siblings modules are already integrated. In this example, S2 is replaced by M2 followed by a replacement of S3 by M3. The same procedure is also followed as in step 1, as the stubs S5, S6, and S7 for modules M5, M6, and M7 respectively are also integrated. Advantages and disadvantages of top-down approach. Advantages of top-down approach. First, your organization realizes a focused use of resources from the individual managed application. Second, the first implementation becomes a showcase for the identity management solution. The disadvantages of top-down approach. First, the solution provides limited coverage in the first phases. Second, a minimal percentage of user accounts are managed in the first phases. Third, you might have to develop custom adapters at an early stage. Now, we proceed the bottom-up approach. The bottom-up approach, again as the name implies, integrates the units from the modules from the lowest levels, called atomic modules, and then works upwards. The atomic modules that perform a specific function are first grouped together in cluster, also called builds. A driver is implemented for each cluster to input and output tests. Consider the same program. Bottom-up integration can be performed on this program. The atomic modules M5 and M6, M7 and M8, and M9 are grouped into 3 clusters. Drivers D1, D2, and D3 are used to test this cluster respectively. After testing, the drivers are removed and the calling modules M2, M3, and M4 are integrated. Another driver can be used to test these modules, and the process is repeated, with the integration working upward. The advantages and disadvantages of bottom-up approach. The advantages of bottom-up approach. First, users and business awareness of the product benefits are realized in the early phases. Second, you can replace many manual processes with the early automation. Third, you can implement password management for a large number of users. The disadvantages of bottom-up approach. First, the organizational structure we established might have to be changed in a later rollout phase. Second, because of the immediate changes to repository owners and the users' population, the rollout will have a higher impact earlier and require greater cooperation. Now, we move on to system testing. System testing may be the term used collectively referred to the various tests performed during software testing, together with the evaluation done by the clients themselves in the environment in which the software is to be installed. The former comprises the activities during unit testing, integration testing, and tests performed on the whole system. The latter consists of installing, testing, and user orientation. The tests performed on the system as a whole use the black box testing methods. These tests can be further classified as follows. Early 1985, the functional, performance, and stress tests. Functional testing involves executing the code using some inputs, values, and check against the expected output. Performance testing evaluates the overall time and device usage. Stress testing attempts to intentionally make the system crash or fail by overloading certain functions. Most black box testing methods commence and emphasize on the functional testing because of its level of importance to all software systems. Some applications, such as real-time systems, may have to carefully perform performance and stress tests as well. Thank you for watching.